let's turn our attention to greening and carbon footprint and carbon emissions. What are you hearing from your developers, and what are you hearing from inside AWS in terms of the importance of attempting to address that from a codec selection standpoint?
Yeah, that's a very good topic. I mean, if we look at video, it accounts for over 60%, if not more, downstream traffic on the internet. There are a lot of energy resources being used for encoding and decoding the content. And in addition, we have to consider how much energy are used to deliver those content across fiber to end users. So there's some optimization done, whether by caching at the edge or just-in-time encoding for the tail end VOD services. Things like we could have cloud encoding instances use less energy by right-sizing the instance type by machine learning, or we could have content-based encoding combined with AI ML to predict what type of content during what time of the day that each household most likely to stream. So Saturday morning cartoons, for example, or Sunday night football. But drilling deeper into encoding, at AWS, we have Graviton processors, which is an ARM64 based processor. And to help customer reduce their carbon footprint, Graviton 3 was announced, and Graviton 3 based instances use 60% less energy compared to the same performance to the x86 EC2 instances. So for a quick test at last year's AWS reInvent conference, we ran X264, a very slow preset input with uncompressed 1080p material. We see about 49% per frame per second compared to the previous gen C6G to the current gen Graviton 3 C7G instances. But if we go back a level and talk about sustainability in general, workload running on AWS are 80% more carbon efficient compared to running at our customers' own data center. And as part of our commitment to net zero carbon future, we're investing more power into our operations with 100% renewable energy by 2025. So combined with a higher computing price performance and improved power efficiency, I really encourage folks to look at other processings such as ARM to help reduce carbon footprint and their costs.
As Kevin mentioned, right, the parameters we're interested in, we'll just say energy consumption, reduce, we want to reduce bits, and we want to reduce distortion, right? And in a system, generally speaking, a video system, you push two of those down, the third one goes up, any two of them, right? And so the answer is, you know, we have to redefine the system to bring to lower the baseline that we're working from, and I'm intrigued by the results that EC2 is seeing with ARM. Definitely from our side, you know, it's you know, I think custom ASICs generally in the past have always been thought of as low quality but cheap from a power consumption perspective. I think that's going to be turned on its head over the next few years. We're investing significantly in ASIC-driven processing, and very happy with the qualities we're seeing, and we're going to continue to push that. We've seen other, you know, Google, for example, has released white papers on the ASICs they've deployed. So I think there's a role then for ASICs as well. So this gives us an opportunity, I think, across multiple dimensions to actually reduce the inherent complexity or the fixed complexity of the systems, so that we can continue to reduce, you know, reduce the energy consumed. And I think it's good that we're looking to clean energy sources, but I think the other side of that is, you know, with continued increase in complexity, with new things like bringing in ML and all kinds of analysis, video is very, very computationally expensive, and generally speaking, pretty dirty in the terms of energy consumption, you know, and use around the world. So I think we do all have a responsibility, and I think that the industry is very serious about that. And I'm really happy with the work that I'm seeing. Again, you know, everything from you know, lower power CPUs to ASICs and more efficient codecs, which again, I'm a plug SVT AB1. The energy, you basically have a dial you can turn, so you can select the energy cost of your compute to do an encode based on the likely value that video will provide in the market. So, you know, you can bring it down to compete with X264 very fast while still significantly reducing the bits. And so to me, these are all great things, I think, we're all aware, we're all of the power consumption problem of the data center growth, and we're all working on it, and I'm excited by what I'm seeing.
Add to what David said, currently with our encoders, we have fast encode preset, quality encoding preset. Perhaps in the future, we have a green encoding preset as well.